Below in the front of the truck on the floor, and I got this one last piece to put in here of sheet metal to complete the sheet metal pieces on this front bumper. And I've cut this piece of foam board like this to fit in here to the shape I want, or pretty close to the shape I want. I'll fine tune it after I cut it on the plasma cutter to get it to fit just right. It's going to take a little bit of I'm going to get a little bit of a gap here, and it's a little bit long, but that's good. That way I can grind a little on the ends and fit it to the final shape. But this is the basic shape I want. And then I'm going to, after I get this fit on here, I'm going to put a 3/8 round bar around the whole bottom lip to kind of help support because this is only, I've covered this with 16 gauge sheet metal because I didn't want the weight to be too heavy to weigh down the front of the truck. The purpose of this isn't to have like a winch or something like on off-road vehicles. A lot of times they put a winch in behind the bumper here, and they have to make it very heavy to take the forces they're going to put on it because the winch pulling on the front bumper. This is just kind of for looks and to make a little bit different bumper than the stock bumper of the truck, and kind of go with the bed that I've made, the styling and such. So this is the last piece I need to cut as far as the sheet metal goes, and then I can start working with this rod. So I cut the template out of foam board. We're going to go over to the plasma cutter and kind of digitize this. Now I've heard it in the comments, well, you could just photograph this, and that's true. And I did that for the smaller parts on this bumper. But when you start getting to these larger parts like this, you get a certain amount of distortion from the lens of the camera, unless, of course, you use maybe a longer lens and got way back from it. I guess that would work. But I find this just as easy, and I can kind of be more guaranteed the shape I want without any kind of distortion from photography or anything like that. If I just do it on the plasma cutter and kind of just digitize it and write it down and then draw it in Fusion. So let's go over to the plasma cutter and I'll show you how to do that. Okay, I already did that part of this, but I lay it down, the template on the piece of material, and I just mark it around there with a Sharpie, and you might be able to see the mark here. And then I kind of tick off places I plan to digitize the line, if you will, with the readout of the plasma cutter's position here. Now I brought the computer down here. Normally I have it setting up on that bench. I don't know if you can see that in the thing up here. The bench over here, or table, to just keep it out of the moisture, and because when you're cutting with this, it tends to throw up a little water from this water table. And I've just moved the computer down here so it's closer up here, so I can do this a little easier. And I can put the mouse on the piece of metal here, and I can jog the machine. Now I'm going to just take the tip off the torch, because the actual nozzle down here is relatively small in size, and I can slow this down a little bit, and I can use it to sort of line up on the line. It's close enough. The tip of this thing is probably a 1/16 of an inch in diameter, maybe a little bigger, and I can use it to do that. Unfortunately, this thing doesn't have real slow jog rate, or you can't really jog it less than 10 inches a minute, which for the purpose of the machine is fine. I mean, you don't really need to do it that any faster than that, but for this it would be kind of nice to have a little finer, maybe a little finer control of it. I'm going to call that, I made a little sketch here of what I intend to, and I ticked off the marks I've ticked off on the sheet metal here and what I intend to digitize. And so I'm gonna zero it, all the axes right there, right at this upper corner, which I've marked. I don't know if you can see this or not, but I've marked this as 0, 0. And I'm just going to go around the piece of material here. And if I can get the right, having this the computer oriented a little different than the actual part is kind of misleading. The actual z-axis on the, I should say something here, I guess. The z-axis on this plasma cutter is only for the purpose of actual adjusting the torch for the height of the material, which is very necessary if you own a plasma, or you're planning to buy a plasma cutter or anything like this. I should say this here, that it's absolutely essential, in my opinion, to have this height control on your plasma torch, because once you start cutting material, these slats that are below here, they get built up with you know, dross and slag or whatever as you cut parts, and there's nothing level about these things after a while, unless you take them off every time, you know, every few parts, and you grind them, all that junk off of there. But if you just start, you know, if you're just cutting material, like I've been cutting quite a bit of stuff here for this truck, and you don't pay too much attention to that, you just pull the parts out, and then you kind of just knock off the slag that's on the slats, you eventually get an unlevel surface. I mean, it's totally unlevel. I don't know if I could even, well, I'm not going to do it right now, but if I jog this thing over here, it's probably an 1/8 to 1/4 of an inch difference in level on between areas on this sheet metal, and even the sheet metal might be bowed or whatever. And if you don't have that torch height control, you're going to hit the tip of your torch on here eventually somewhere, and then the machine's going to stop. And with the stepper motor control, you might even lose positions, and then you got to go re-zero back to your original 0 and hope that you got it correct. And it's a little bit, it's not like a regular machine. Once you set that 0 point, and you got feedback control on the machine, you could re-zero, return it, and come back to your original position. But you really can't do that this way on these kind of machines. So if you're going to buy one, whether it's this Langmuir system or whatever kind of plasma cutter, get the height control on the torch, because it's kind of necessary. I mean, if you were to clean these slats every time you cut something and make sure they stay clean, maybe not. And if the pieces of material are pretty flat that you're cutting, but it's way better to have it, believe me. That's just my opinion, I guess. I mean, I'm no expert on this stuff, but the z-axis actually doesn't really do anything but control the height of the torch on these things, but it's really pretty necessary, I think. So that's the first point. I'm going to go call it 6.255 and 0.966 in Y. I'm just writing these down. I put the X first and then the Y, like that. I'll go up a little bit with the torch. Let's move over in X to some position over here. It's not really, like I say, necessary to be in the exact position, just so you're on that line somewhere, fairly close. It'll be close enough for the purpose of this. So 12.655 and Y of 1.5. So I'm going to go around and digitize all these points, and then we're going to go over to the computer and sketch this up in Fusion, and process the tool path to cut this part, and then we're going to cut it and then fit it to the truck. So let me come back here after I get all this digitized over on the computer to draw it. Alright, here we are in Fusion. We're going to start this sketch. So I'm going to go over to sheet metal, although it doesn't really matter if you start it in sheet metal though, but I'm going to start a sketch on this plane. I'm going to look at that plane directly from the top. I'm going to create my point at 0, 0. That's going to be my first point, which corresponds to this point. And you know, there might be, I'm no Fusion expert, so bear with me here, but I'm just going to draw. I don't know what scale this is at. Well, let me dimension this first point so I can kind of get an idea of what scale I'm. 6.255, 6.2. You know, there might be a way to do this to where I can enter these dimensions as I make the points. I don't know. 0.966. Okay, so that kind of gives me an idea of my scale. I'm just going to draw my points in here roughly. 0.788 for this point, and the height of this point. And so maybe there's probably a lot smoother ways to do this. 0.430 for the Y. Okay, so that's our points. Let's zoom in just a hair on this. That's our points along the top of the curve as we digitize. Now, let me create some points down here for the bottom of this. See, it wants to put it's snapping to the grid. I mean, or it's snapping to whatever points I've already got there. So let me dimension these. All right. Now, we know that this point from here to here is just a straight line. So we can draw that, and we can also draw that. And then we're just going to draw us a spline between these points. And that's the one side, and then the other side here. Like that. So that looks pretty good, so we're going to finish the sketch. So there's our sketch. Now we're going to make a flange out of that, and I'm going to change the direction of the flange to downward. Although that really, and you can select a material type on here if you want. It really doesn't matter in reality, but because you're going to control the feed rate and everything when you do the program. So now we're in sheet metal right here, fabric. We got to go to manufacture, and we've got to do a setup, create a new setup. And you could almost use this just as it is, but I put 0, 0 over here on this corner, so that's where I'm going to put it for this. You could change this to cutting. A lot of this stuff really doesn't matter that much. As far as this, I found that for some reason, if I wanted to select this, well, I could actually put it on this one. A lot of times I change this from where this is the center of the part or stock or whatever you want to call it, but I'm going to put it my 0 point at the model origin over here, because that's where I started and that's where the machine knows it is. And over here, I'm I'm just going to set the stock out wider than the part so we can see it in simulation a little better. I'm going to make this number 0, and that's all you really need to do for a setup for this plasma torch. And then we're going to come over here and create our actual cut. We're going to select a tool. I've already defined this tool the way they said on the Langmuir website how to do it, and I know on this material, this 16 gauge, I feed about 60 inches per minute, and that seems to work pretty good. So I set all those to 60 on that box. Then here's where you define the shape you want to cut. You just select it, and that's pretty much all you got to do there is select it, and it looks all right just looking at the arrow and what side of the part it's on. You got to make sure it's on the side you want, and then go over here, and I'm going to put this in the computer because the Langmuir system, I guess, doesn't do cutter comp, so this compensates for the width of the cut, the kerf, if you will, in the computer when you make the code. I'm going to go over here, and I'm not going to put any lead out, exit, lead in. Doesn't really matter in this case. Just set it to 90 degrees. But I'm going to select this corner of the part to start on over here, because if you start, it usually will start way over here on this corner if you just let it process it. And if you cut the part off of the bulk of material, you can have distortion, so it's better to cut around the thin side of the material, or in this case the front side of the material first, and finish up here so that you don't get distortion. If you cut this back side first here around this side, the part will be separated to some degree from the stock by the time you go around here, and it could make it not the shape you want by the time you cut this to finish over here if you just let it do what it wants. So I select this upper right corner usually when I'm cutting a part like this long like this. A small part, it doesn't matter too much. And let's see if I got everything else right. Yeah, so I just go OK, and see, now it puts the start point over there. It actually seemed like it wanted to select the 0, 0 point to start with. But like I say, you're going to be cutting this off the main bulk of material. It's similar to the way you do wire EDMing. You don't do this either, because if you get some stress or distortion, the part won't be the right shape. So anyway, let's simulate this. And it seems like it looks all right. Okay, so I'm pretty happy with that. I'm going to grab this USB stick out of the plasma cutter's computer, and I put it over here because I've got this automatically to set it to that USB stick here. And we're going to I'm just going to name it last part. And that's okay, we can just post it just like that. It'll put it to that stick and call the program last part. So now we're going to take this USB stick here and just plug it into the computer over here, just like that, and go over there. I don't have a screen capture thing on that computer, so I got to take the camera over there and show that. I've got this part on the stick. I plugged it into the USB port, and we call it the last part, remember? So I got to bring it into the software, and here it is. Now I'm going to go, right now it's setting on the last point I digitized, which actually looks pretty good just looking at the thing. I'm going to tell the machine to go to XY0, should be right there. And really this is ready to cut right now, except that I've got to turn on the plasma cutter and everything. I got the compressor on already. So let me turn that on over here. I got to plug in the air line to it. And make sure I got it plugged in. I do. I hit reset on this HTP plasma cutter every time you turn it on. That's the way it works. Okay, now we get the plasma cutter on. Everything is pretty much ready to go here, and because I digitized everything, you know, on the machine, it's all set up pretty much. You know what? I forgot to hook the ground onto the material. I often do this, and it starts to cut and it kind of screws up. All right, now let's start things. So we're going to select start here. The machine's going to come over to this come down and set the torch height and go. Okay, so the cut's finished. Select OK here. And move this up out of the way so it doesn't keep blowing that air through the slot. Like I was saying before, now if you notice, if you started over here like the software wanted to, and you cut this along here, and then you came around here, you see how this is opened up here? Because of, I don't know if it's stress in the sheet metal or whatever it might be, but if you cut it off the bulk of material right here down this way and came around like the software automatically wants you to do, this would be off, of course, because it would have moved. It could have moved. Maybe not, you know, it depends. So anyway, that's our piece. Now we got to clean off the you know, the dross that it left a little bit. Go fit it to the truck. Here we are with the piece cut, and I put it up against the truck, and I knew it was going to be large, and I think it's a little bit long here on the top because of the thickness of that foam board. The foam board's almost 1/4 of an inch thick, or around 1/4 of an inch thick, and it was out here more, and I want to try to weld this right to this piece right here is like this one, and I want to weld it kind of to the bottom corner, because then I'm going to come back and put round bars on top here, kind of like this 3/8 round bar, and come out here in certain ways, and I'm going to go around the bottom of it, the whole thing, with a 3/8 round bar as well, like this, just to kind of give it some strength, because this is just 16 gauge. So I kind of rigged up a thing on a felt tip pin, so I could kind of just mark it roughly here, you know, along, holding it kind of like this thing like this. I don't know if you can see, it's got kind of a wire. I taped a piece of welding rod and bent it around such that it would be kind of lined up with the tip of the Sharpie, and then I could mark it roughly here. And it gives me an idea of the curve I need to grind in there. You can see this is overlapping a little bit, and I got to trim it back to about this much. But I think that was because that 1/4 inch foam board was sitting out here further, and I wasn't really super careful where I put this. But I knew this was going to be an issue, so I'm allowed for some trim. So let me grind this or cut this off, or however I'm going to do it. That's looking pretty good now. I'm liking that. I've got a spot here to weld. I may have ground just a hair too much there, but I don't know until I push it back this way, because it changes shape a little bit. if you put too much force on these pliers, see how it kind of changes. And that kind of controls the gap here, but let me although that's not that bad of a gap to fill with the weld, but I want to grind it off anyway. This has a little bit of a bow in it right here. It might actually partially come out. But first I have to can't put too much tension on these vice grips because they're not really clamping there, and they'll tend to bow this bottom out. Let me get the welder and tack this in a few spots along here. Let's see how it looks. Okay, let's see. Now I just have to weld this up. Like I said, I'm going to put some, I think I'm going to take 3/8 round bar, and I'm definitely going to go around the bottom with it here on this. I might put one piece going across here and then start another piece and go all the way around there. I'm going to take some as well. Let's see, I've got a piece here somewhere. Where did I put it? And I'm going to put it on top of the here and kind of bend it and go around and stop it and kind of taper it down here and weld it to the sheet metal here. On these, I'm not sure if I'm going to put it on the top yet. Maybe. I might do that too. Just to give it a little extra look. But that's how I fit a piece of sheet metal on this. I mean, this one took a little more time. These ones I cut and they've just about fit exactly right after I bent them here. Oh, I don't have a brake, but the way I do these bends is on this 16 gauge, it works pretty good. You score the back of the material with a abrasive cutoff disc, you know, in the angle grinder, and then I can just bend it over the edge of that bench, or that steel bench I have with the vices on it. I can clamp it on there and just bend it down, and it makes a real nice crisp bend. I don't know if you can see that. See how nice that bend is? And you just score it about 1/3 of the way through the sheet, I guess you might say. Just it takes a couple of passes with the abrasive disc, and then just bend it over I bend it over the edge of that steel plate on the bench and clamp it down with a bar on the bench and just hit it with the leather hammer or dead blow hammer or something, and bend it. You can see here I got a little bit of a gap to bridge here, but it's fitting pretty good all the way along here. Right there. So I just got to weld that on here. It might not have to be a continuous weld because I'm going to cover it up with that round bar and weld it on top. Kind of like this plate, this license plate thing. I bent this 3/8 round bar around it, and then it sets in there. welded some nuts on the back so that I can just screw it on. So anyway, that's the bottom piece to the bumper.